Alright, let's talk about foundries. It's a tough, gritty business. You take raw metal, melt it down in a furnace that's hotter than the sun, and pour it into molds. It's an amazing process, really. But when those castings cool down and get knocked out of their molds, they aren't exactly ready for prime time. They're covered in sand, scale, and all sorts of other gunk. They look rough. This is where wheel blasting comes in. You quote, reusing tiny metal pellets called shot. The goal is to get those castings perfectly clean, so they look good and are ready for the next step, whether that's painting, machining, or shipping them off to a customer who expects a quality part. The whole operation hinges on that cleaning process. If you don't get a good, clean surface, nothing else matters. A poorly cleaned casting can cause big problems down the line. Paint won't stick properly, which means it will peel and flake off later. If you're trying to machine the part, any leftover sand or scale can ruin your expensive cutting tools in a heartbeat. That's a costly mistake. So, the quality of the blast cleaning isn't just about making things look pretty. It's about ensuring the final product works the way it's supposed to. It's a critical step that a lot of people don't see, but it's absolutely essential for making a part that is both reliable and functional for its intended purpose. To do this job, foundries rely on massive machines called wheel blasters. These things are impressive. They have a big wheel inside that spins incredibly fast, sometimes thousands of rotations per minute. This wheel acts like a slingshot, grabbing the steel shot and flinging it at the castings with tremendous force. Imagine thousands of tiny hammers pounding away at the surface all at once. That's what's happening inside that machine. This aggressive action is what strips away all the unwanted material, leaving behind a clean, uniform surface. It's a loud, powerful, and frankly, a dirty job. But it's a necessary one. Without it, you just have a rough, unfinished piece of metal. Now the stuff you're flinging at those parts, the abrasive, is incredibly important. For a long time, the go-to choice has been cast steel shot. It's relatively cheap and it gets the job done, or so people think. But here's the dirty little secret. The quality of that shot makes all the difference in the world. Using the wrong kind of shot, or even just a low-quality version of it, can turn your efficient cleaning machine into a money pit that creates more problems than it solves. It's one of those details that seems small but has a huge impact on your entire operation. From the health of your machines to the quality of your final product and even the safety of your workers. So, what's the big deal with cast steel shot? Well, it all comes down to how it's made. To make it, you melt steel and drop it into water. As those little molten droplets hit the water, they cool rapidly and form into tiny spheres. The problem is, this process isn't perfect. It's fast and cheap, but it often creates tiny imperfections inside the shot itself. Think of it like a chocolate candy with an air bubble inside. These defects, known as blowholes or porosity, are weak spots. Now you take this imperfect shot and you put it into your wheel blaster. That machine, as we discussed, is a violent environment. The shot is accelerated to incredible speeds and slammed against a hard metal casting. What do you think happens to a tiny brittle sphere with a hidden crack or an air bubble inside? It shatters. It's like throwing a glass marble against a brick wall. Instead of bouncing off and being ready for another round, it explodes into a bunch of smaller, sharp, and mostly useless pieces. So, right from the first impact, your expensive abrasive starts breaking down into little more than dust and debris inside your machine. This is where the real trouble begins. You bought that shot to clean parts, but a significant portion of it breaks apart on the very first hit. Instead of having a consistent size of round pellets doing the work, your machine now has a mix of good shot, fractured pieces, and fine dust. These broken fragments are no good for cleaning. They're too small and too light to have any real impact on the casting. They just bounce around, creating a cloud of dirt and contributing nothing to the cleaning process. You're essentially paying for a product that self-destructs almost immediately upon use, which is not a very efficient way to run a business. This constant shattering has a compounding effect. The more the shot breaks down, the worse the problem gets. Your operating mix, which is the blend of abrasive you're actually using inside the machine, becomes contaminated with these fractured particles. The machine's separator system is supposed to filter out the broken down shot and dust, but it gets overwhelmed. It can't keep up with the sheer volume of debris being created. As a result, you end up blasting your parts with a mix that is less effective, which means your cleaning times get longer and the quality of the finish goes down. Let's talk about dust. When cast steel shot shatters, it creates a massive amount of fine metallic dust. This dust fills the inside of the blasting cabinet, creating a thick, dark cloud dot. Visibility goes right out the window. Your operators, if they need to look inside, can't see a thing. More importantly, this dust doesn't just stay in the cabinet. It gets pulled into the dust collector, which is the machine's lungs. The dust collector is designed to handle a certain amount of dust, but the rapid breakdown of cheap shot overloads it. The filters clog up faster, requiring more frequent cleaning or replacement, which means more downtime and more money spent on maintenance. This dust cloud isn't just an inconvenience. It's a major cause of wear and tear. All that fine abrasive dust gets into every nook and cranny of your blasting machine. It works its way into bearings, motors, and any moving part it can find. Think of it like sand in your engine. It grinds away at critical components, causing them to fail much sooner than they should. The blast wheel itself, the heart of the machine, takes a beating. The blades, control cage, and impeller are all being eroded not just by the good shot, but by this storm of sharp, broken fragments. This means you're replacing these expensive parts far more often than you should be. The shattered pieces of shot also ruin the cleaning process itself. A wheel blaster is designed to create a specific blast pattern, a carefully aimed stream of abrasive that provides even coverage on the part. This pattern is calibrated based on using round, consistently sized shot. But when your operating mix is full of tiny fractured particles, that pattern is destroyed. You get an uneven blast, with some areas getting hit too hard and others barely getting touched at all. This results in a poor quality finish. You'll see spots that are still dirty or have an inconsistent texture, which means the part might have to be reblasted, wasting time, energy, and more abrasive. So you have a machine that's wearing out faster, a dust collector that's working overtime, and parts that aren't getting cleaned properly. It's a recipe for high operating costs and a lot of headaches. The initial savings you thought you got by buying cheaper cast steel shot are quickly eaten up by increased maintenance, more frequent parts replacement, and lower productivity. You're stuck in a cycle of constant repair and poor results. All because the abrasive you're using is fundamentally flawed and not up to the tough job you're asking it to do. So, if cast steel shot is the problem, what's the solution? It's something called cut wire shot. And it's exactly what it sounds like. It's made by taking a high-quality steel wire and simply cutting it into small pieces. The length of each piece is the same as the diameter of the wire, so you get these perfect little cylinders. Because it's made from a solid drawn wire, there are no internal defects. No blowholes, no cracks, no hidden surprises. It's a solid piece of metal, through and through. This fundamental difference in how it's made is why it performs so much better in the harsh environment of a wheel blaster. When you use cut wire shot, the first thing you notice is the massive reduction in dust. Since the shot is solid and durable, it doesn't shatter on impact. Instead of exploding, it wears down slowly and evenly over time, like a bar of soap. This means you're not creating that giant cloud of dust that clogs your dust collector and sandblasts your machine's internal parts. Less dust means better visibility, a cleaner work environment, and a dust collector that can actually do its job effectively without being constantly overwhelmed. Your maintenance team will thank you because they'll spend a lot less time cleaning and replacing filters. The durability of cut wire shot also means it lasts a whole lot longer. Because it doesn't fracture, each piece stays in the machine doing its job for a much greater number of cycles. We're not talking about a small improvement here. We're talking about an abrasive that can last 3 to 5 times longer than conventional cast steel shot. This translates directly into lower cost. You buy less abrasive over the course of a year, which saves you money on material costs. You also spend less time stopping the machine to add new shot, which means more uptime and higher productivity. It's a simple equation. A tougher product lasts longer and saves you money. Ultimately, switching to cut wire shot is one of the smartest moves a foundry can make. You get a better, more consistent finish on your parts because you're always blasting with uniformly sized abrasive. Your machines last longer because they aren't being torn apart by dust and sharp fragments. Your operating costs go down because you're buying less abrasive and spending less on replacement parts and maintenance. It might cost a little more upfront, but the long-term savings are undeniable. It's about looking at the total cost of the operation, not just the price on the invoice. Don't forget to subscribe to FoundryPlus channel for more. Let me know in the comments below what you thought or what you'd like to see next. Bye.